Hello, my name is In-Young Park. I graduated from University of Washington with a physics degree, and I made this video because I wanted to share a long question that I had, which is, what is the economic cost of a single lane swap in times of traffic? To do this, I made my own simulation program, which best of my abilities try to emulate what it's like to be on the road. So you can add any number of lanes. You can add cars as specific lanes, and we can keep adding cars, and we can have them all switch lanes at a certain frequency. Now the data it collects is the amount of cars past a certain distance at a certain time, and I speculate that for the case where cars are changing lanes more frequently, it should be significantly lower than the case where no cars are changing its lanes. I can change the parameters however I want, so I can have it accelerate faster, and have it have a faster speed limit, or I can have it change its lanes at a much slower rate, or have it change really frantically. I can also change the data update timer and the distance increment, so that if you are thinking about taking a really long data, you're not stuck with a billion point. So for this experiment, I use these parameters. So each car goes from 0 to 90 in about 5 seconds. It takes about 2 seconds to come to a complete stop. The speed limit is 90 kilometers per hour. Number of lanes is set to 4, and it adds cars whenever there's enough space to add cars. And I made the run for 10 minutes at 5 different frequency of no lane switches, 1 lane switch for every 100 seconds, 1 per 10 seconds, 1 per 5, and once every single second. So for example, I can import one of the datas over here, and we can see that the cars in average switches its lanes in about every 5 seconds. It ranges from 0 to 10, but should average to 5. And here are some of the data. Now if I save this into a text format, it comes out nicely like this, which then I can use R to get a visual representation of it. So here's a simple 3D plane graph stacked all together. As you can see, as the number of frequency increases, the amount of cars passed decreases. Now if we take a 2D representation, setting the time to be at 10 minutes and distance to be at 0, you can see that there is a significant drop in number of cars depending on your frequency of lane switches. And here I thought, if I were to take the integral of this number of cars passed by the distance, I can get the total amount of distance covered by all the cars on the road. Same for time. And with that, I can calculate how much economic value we're losing. So using the regression lines from the previous equation, which all had R square of close to 1, so should be pretty accurate. I made a integral graph below, and we can see that if everybody were to change their lanes every 10 seconds, you're only getting about half the economic value as to the case where nobody is switching their lanes. Now the real question I wanted to ask was what the economic value was from a single lane swap. To do that, I took the integral of the number of cars passed versus time to find the total amount of time spent by all the cars, and thought that if I were to divide them by the frequency, I can calculate the total amount of lane switches, and then I can use that number to divide the discrepancies over here to the control, and I can see what exactly the cost was for a single lane swap. Now, surprisingly, we see that as there are more lane swaps, as the frequency of lane swap increases, the economic cost decreases exponentially. And I think that's because when there are traffic, majority of the cars are going to be at traffic, and if you're moving at a much slower rate, it makes sense that you're not losing much value from switching the lanes. But speculating that in a real life scenario, people fall within the range of switching your lanes every 100 seconds to once every 10 seconds or so, you're costing about distance of 500 meters for somebody, and about 300 times 20 milliseconds, so about 6 seconds for somebody else. So if we were to put that all in a more relatable values, we can see that if you switch your lanes every 100 seconds, it costs about 2,200 kilometers overall, and about 7.4 hours. And if you switch your lanes for every 10 seconds, it increases to 3,600 kilometers and 20.4 hours. Now, this is only 10 minutes of data. If we actually increase the number of minutes, the values lost gets increased significantly as well. So if we take the data for 30 minutes, the total distance lost from people changing their lanes every 100 seconds gets from 2,200 to 24,000 kilometers. If you change your lanes for every 10 seconds, the economic cost increases from 3,600 to 36,000 kilometers. Same for hours, 7.4 hour increases to 94 hours, 20 hours increases to more than 200 hours. And if we plot the data in and make a table of it, we can see that the distance lost and time lost increases exponentially. So in a case where you're stuck at a traffic for about longer than an hour, you can only guess how much value we are losing. There is also an increasing trend for distance and time lost per lane swap, but like I mentioned before, the values could be a bit erroneous from all those cars switching lanes without much purpose. So yes, thinking that everybody falls within the range of these two values, I say in average, if you switch a lane, you're costing somebody about 500 meters and about 10 seconds. So yeah, Of course, there are a lot of limitations with my program. First of all, that all the cars are changing its lanes randomly. It doesn't have the complex thought process of passing, overtaking another car. It could with no purpose switch to a slower lane. And also there's a problem that all the cars are switching their lanes instantaneously. So if you think about in real life how every time a person switches lane, they're taking up 2 lanes worth of space. So if I could actually program that, it could increase my numbers, I speculate. And also there's a problem that in my program all collisions are ignored, so hence it allows all those lane switches to occur when all the cars are sitting in traffic. And yes, that's it for my video, and thank you for watching. This has been very interesting for me, and I hope listening to this was interesting for you as well. And final point is that I can't wait for self-driving cars to come out. And thank you.